you that I couldn't collect an electrocochleography response in this room. If I was careful, I can get an ABR. I can certainly get a vamp, but I couldn't get an EChocG. Sure, it's the smallest response the human body makes, so you need clean, electrically clean things. And besides that, we got the low filter real low, where the bandpass is 10 hertz to say 1500. Not 100 hertz, 10 hertz. So what could we do when we have interference like that? This is good for ABR and EChocG, both. Well, one thing we could use is shorter test leads. Notice that on the Tiptrodes, the leads are 40 inches. Maybe not 40 inches, but I think they are. Yeah. And the longer this lead is, the more this is an antenna that's picking up things. Okay. A shorter lead would be better. Okay. They don't come in shorter leads, but shorter leads would be better. Okay. It might take some innovative thing like cutting and splicing this thing, but to give yourself a shorter lead would be helpful. Okay, so shorter leads in general tend to pick up less noise. You could put the 60, if your piece of equipment has a 60 cycle notch filter, you could turn it on and try it. In many, many cases, that'll solve it. Okay, it does take a piece of the pie out. It does diminish the response slightly, but you could get away with it. You couldn't get away with moving the low filter up to 100 or 75 or something, moving it up past 60 cycles. You couldn't get away with that. But the notch filter, if it's a narrow enough notch, you could get away with that if you have to. Otherwise, don't put that on. Sometimes the interference is of a higher frequency. It's not 60 cycle or 120. It's a higher frequency, a multiple of 60 cycles. So you can bring the high-pass filter, if you normally have it at 3,000, bring it down to 1,500. Okay? Naturally, the more narrow the bandpass, the less interference problem. Another thing that's very good, the front end of this equipment are all differential amplifiers. Differential amplifiers are most efficient at rejecting noise when the impedance is equal between left and right. So one ear's 3,000 hertz electrode impedance, and the other ear is 13K. Say one ear's 1K, very good electrode impedance, and the other is pretty bad, say it's 10K. Well, we're not going to get optimal noise rejection out of the differential amplifier. It's called common mode rejection. So to enhance the common mode rejection, make the impedances as equal as possible. Whichever one is higher, scrub better. Okay? Turn the gain down. I was trying to, right before we started this class, I was trying to actually acquire an EChocG response in this room, regardless. And I came pretty close to doing it. I had to turn the gain down. I was actually watching my EEG, and I could see the noise in the EEG. And by turning the gain down, I was actually able to acquire a response. I just couldn't operate with the low filter low enough in this environment. But you could lower the gain a notch if you have to. Don't go down in EChocG. Don't go down past 50,000. You could braid the electrodes. Braiding the electrode wraps the ground electrode around the other two, and it kind of acts as a pseudo shield. Okay. It is a single channel test. If you have it set up as a dual channel test, change to a single channel. All right? Less likely to pick up noise. Watch the lead dress, in other words, so you don't have the Tiptrode lead actually wrapped around or even crossing the transducer. Now you're picking up stimulus artifact. You're inducing stimulus artifact out of here, electromagnetic artifact right into this lead. Okay? That's no good. So just watch how you have to keep it separated. Sometimes this works wonders. A power line filter. Not a surge protector, that's nothing. A power line filter that goes by the brand name Monster. Okay, you can get it at Best Buy. And what it does is it actually filters the line. So when you have noise and crap on the power line, this cleans it up some. And in some places, that's all we do is plug the equipment into that Monster filter, and presto, like magic. Okay, it's not going to solve every situation, but in many cases, that's all you needed. The thing's less than $100. This is going to extremes. I did it one time. Where was it? Can't remember where in Alabama it was, but there was an AM transmitter right down the street. Okay, not the Gadsden thing. This was a different case. And I couldn't get anything to work. I actually used RF filters. They plug in where you would normally plug the electrodes in. They're ferrite beads. But an RF filter plugs in there, and you plug the electrode into the filter. Little tiny filter. You could use that. That's only good when it's high frequency interference, like I was getting from this AM transmitter. Okay, it won't do anything about 60 cycle. That's these RF chokes. RF choke, you can buy them in Radio Shack, and you can actually put them in places like this. You can put them on here. This is the patient cable on this piece of equipment. You can actually put them on here and on here if you wanted to. And they will also reduce as RF passes by them, it'll choke it. That's why it's called an RF choke, ferrite bead. Some amplifiers have a very, very broad, these preamplifiers on ABR units, some of them have a very, very broad bandwidth, okay? Ridiculous. Like the Nicolay Spirit had a very, very broad bandwidth. We solved problems by making engineering, sending it back to engineering and having them reduce the bandwidth to like 1/4 of what it was originally to overcome noise problems. And of course, if you have older analog equipment, dump it, get the newer digital equipment, because it's like night and day, as you'd expect, as it is with hearing aids, as it is with records versus tapes versus CDs. Digital processing is cleaner, more noise-free. Okay?